Traffic delays in and around work zones are not new to the traveling public. The Texas Transportation Institute estimates that $78 billion in fuel consumption and time is wasted annually in traffic delays. To mitigate this problem, innovative methods for shortening project construction times are being used to minimize lane restrictions. It's simply a better way of doing business. Accelerated Bridge Construction, or ABC, is one such innovation that has been widely used to minimize construction-related traffic disruptions throughout the country. ABC is any technique that speeds up construction of bridges, thereby reducing impacts of construction to the traveling public. Precast elements are often used to minimize on-site construction times. As ABC gains momentum, the practice is making its way into the higher seismic regions of the country. In those regions, ABC methods must be combined with appropriate construction techniques to produce quickly built but seismically rugged bridges. The Highways for Life Technology Partnerships Program provided a grant to Berger ABAM to develop prefabricated bridge bents that may be used in areas prone to seismic activity. The Washington Department of Transportation used this precast bent concept for construction of a new bridge over I-5 south of Olympia, Washington, one of the more heavily traveled corridors in the state. ABC includes such elements as prefabricated modular units that are built off-site in a controlled environment and then transferred to the construction area for rapid installation. The connections between such prefabricated elements must be able to resist seismic loading. The innovation used here for seismic regions comprises robust connections that ensure that large seismic forces can be transferred between columns and foundations and columns and cap beams. Testing by the University of Washington has proven that such connections can be made both constructible and seismically resistant enough for all seismic regions. These connections can transfer the full strength of the members they connect. Under a simulated earthquake loading, all damage in the precast assembly is confined to the column. The adjacent element experiences no damage, emulating cast-in-place construction performance. Bridge superstructure construction has been accelerated for years using precast, pre-stressed concrete girders. However, we are only now developing fully precast bents that can be used in high seismic regions. In this project, a foundation is prepared and precast column elements are cast with the foundation. Second, column sections are erected above the first column element. This step may be omitted by using a single column for a short bent. The demonstration project used the segmental column option to prove its viability. Then, the cap beam is set, the columns are grouted, and the cap beam closure pour is cast. Finally, girders for the superstructure can be set and the bridge is completed from that point as usual. This project demonstrated that the new types of connections were constructible and save time, but they require extra attention to detail, such as the use of mock-ups to minimize field problems and ensure quality construction. The use of the precast cap beam, in particular, helps reduce construction time in the field. This project takes precasting to the next step in substructure construction, opening up a new era for accelerated bridge construction in seismic regions. For more information on the fully precast bridge bent for use in seismic regions project and the Highways for Life Technology Partnerships Program, visit their website.